I don't know about you, V.
Well, all of us have a sense of power in the relationship.
But you know the stretchy shoestring things I'm talking about that have the slider? Are those stupid?
I've never seen one of them.
I don't know.
Never seen them
for a
in
while.
real life, but I
think people
understand
generally
what you're
avoid
talking
them.
about.
You would avoid them?
I
Why?
think people just avoid them in general because I don't ever see them.
Yeah,
Like they're mostly on like water shoes. Where you see them.
Yeah. Yeah, those things are great. See those?
That's a different one. That's a
See, they're
slightly fancier one.
they're stretchy. So that way you don't even have to untie your shoes. You can put your shoe in, but it stretches up so you can get in there without like crushing your shoe. Super good.
You guys remember those shoes that have were actual feet that had toes and everything? Oh,
They still have those.
really? I thought those were out of business a long time ago.
Oh, I mean, at least they still exist today. Maybe it was a specific company that did it or something, but there's a personal trainer at the gym that I see that has those, which seems like a really bad thing because now, I mean, it's one thing you drop weights on like a normal shoe and break a toe, but now your toes are individually provided. It just seems like that would be worse.
They're really uncomfortable.
Are they? So what's the purpose of them?
They're supposed to make it feel like you're burning fire.
Those toe shoes are good for climbing.
Okay. Because I guess
I don't know. My brother-in-law is into rock climbing and he does all his own stuff.
they probably let you get an individual little toe into a.
Into the rocks.
Yeah, you can't get the whole foot there, but you can get a big toe in there or a little toe in there, and just support. All right. So let's keep trucking today. Let me get rid of this stuff so you guys can't cheat. Well, I'm not giving you the same stuff anyways, but I'm showing you some new things today.
Okay.
All right, so we already had the slide that says we have not. All right, so if we go back, if you remember when I teach, we can't connect to iCloud, huh? So Falconet's down. Yeah, it'll connect at some point. So, come on. It's fine. It's offline. I will accept that. All right, so I can't use Keynote if it's offline.
That seems kind of weird. Is it because it's a shared thing?
It's back online. It's ridiculous. Okay. So we go back to our beginning programming classes, the how do humans solve problems. And remember, we have memory, asking questions, repetition. All right, and every programming language has facilities for these three things. All right, so scheme, we've already talked about how memory works. That's through the define function. Right, so we saw this last time. I can say define A to be 15, run, and now I have a variable named A that's equal to 15. Poof. Create variables. Name value pairs. All right. Asking questions. In scheme, this is going to be done. Initially, we're going to do this just through if statements. I'm going to show you another structure a little bit later on, but we're going to do it through if statements at first. Okay, so this is going to be an if. So let's look at if statements. Oh, beautiful. I think it's when I'm on guest, it can't connect, but apparently Falconet can't be joined at this exact moment. All right. Should be on now. So we have if in scheme. Now remember, scheme, everything is a function. So we go back somewhere in one of my slides here. I have how scheme function calls work. We have open parenthesis, the name of the function, followed by technically 0 or more parameters, but there's usually going to be one parameter at least. So for if, we have open in parenthesis, the word if. Then we have Boolean expression. What's a Boolean expression?
Returns 1 or 0. True.
Any expression boils down to a single value of true or false. Then we have the true expression. We have the false expression. All right, so there's 3 parameters to an if. The first parameter is the question you're asking. The second parameter is what do you do when it's true. The third parameter is what do you do when it's false. Make sense? Mm-hmm. All right. So, for example, we can say if less than A5, return a 20, otherwise return a 30. Something like that. One of the mindsets you want to get down to, if you remember when I first, a phrase I often say with programming is something boils down to something else, right? Instead of returning a value, I say it boils down to a value, but becomes another value. Scheme really emphasizes this. I'm not using a return statement anywhere. This if, and let's actually just see it in real time here. So A is 15, right? So if I say if less than A5, this is a function called less than that takes 2 parameters, 2 values, and we're asking the question, is this value less than this value? And that's a Boolean expression. It'll boil down to true or false. So is 15 less than 5? It's not. Okay, so this will be my true statement. This will be my false statement. So this expression right here boils down to a 20 when A is less than 5. It boils down to a 30 when A is not less than 5. Make sense? So right now A is 15. Is 15 less than 5? No, it's not. So this should boil down to a 30. Make sense? What?
Is there a difference between boil down and return?
No. But keep in mind, boil down is my phrase. This guy right here, in all of its fanciness, boils down to a single value. Either 20 or 30. But it doesn't have to be numeric. I can say it boils down to greater than A2. So is 15 less than 5? Nope. What's the result of the greater than function being applied to the parameters A and 2? Go ahead.
Well, this would be true in this case, but I've got a question.
So that's the answer. The answer is this boils down to true. This is a Boolean expression. Greater than A2, A is 15. Is 15 greater than 2? Yes, it is. This only happens in the event that this is false. Is 15 less than 5? It's not, so this is false. So we execute this, which boils down to true. All right, go ahead.
On an implementation level, this if function, is it going to evaluate both the true and false expressions before returning 1?
No.
Or it will determine which one to evaluate
That.
when it gets there?
Yep,
Okay.
just like in any traditional programming language. Yeah.
Okay.
Question, do we have else statement?
This is the else.
No, like if you have a lot of else statement.
Yes, we have something called a cond, which I guess I can show you now, but you can accomplish it through this. You could say, let me kick this down. So I'm gonna, a lot of times pressing enter after that indents things a little bit better. So we can say, if this is true, do this. But we can then ask another question. We can say, if A is greater than 2, then
You're missing a parenthesis.
I won't be.
Okay.
Then 7 or 12. So now this is kind of an else if. So we're saying, if this is true, just do this. Else if this is true, boil down to 7. Otherwise, boil down to 12. And if I'm staying...
The only way to do more than one else is if it's nested.
No. The only way I've shown you is if it's nested. Let me rewrite the same thing using the other structure. We have a structure called a cond. So I can say condition less than A5, boil down to 20, greater than A2, boil down to 7, else boil down to 12.
I kind of like that more.
Well, they serve different purposes. So, I mean, you know, this guy here, I would say if you're only asking 2 questions, a nested if like this might make sense. I mean, keep in mind, you're asking a question that is theoretical in nature because it might not be something you actually need to do. Always use the right tool for the job. Typically, what we're going to see in here, we're going to use a lot of cons because when we're building a language, we're going to be asking, is the function you're calling, is it an if? If it's an if, do this stuff. If it's a define, do this stuff. If it's a less than, do this stuff. If it's a greater than, do this stuff. We're going to be having a big con for which particular function is your interpreter currently calling. That makes sense? All right, so sometimes cons are the right job. A con would be equivalent to something that we actually don't commonly use in programming today. Not that people don't use it, but it just has kind of fallen out of, I guess, vogue, is something called a switch statement. Okay, so most of our modern languages have a switch statement in it. I don't teach switch statements. Because they're a little bit dangerous because they rely on you having breaks for this fall through thing, so the logic can sometimes be a little funky. And almost all of our languages now support an else if kind of shortcut, which effectively makes it look like a cond, which effectively makes it work like a switch statement. The one advantage of a switch statement, without getting into too much Java stuff, let's say, is it technically would allow you to have a spill-through effect, where if you avoided breaks, you could have 2 or 3 different things fire in a switch statement. I don't want to talk about that right now because I'm not teaching the breaks thing on Java, but you don't actually have to leave the statement if you don't want to. You can say, if this is true, do this, but go ahead and check the rest of this crap too, and potentially do some other things. You can accomplish that in C, C++, Java. Switch statements have been around for a long time. I just think that almost always, when you're asking questions, you want to ask a question and make a single maneuver based on that question. If you're solving an advanced enough problem where a switch legitimately makes the most sense for that one weird spill-through effect, you probably are a good enough programmer where you can go look at the syntax for a switch real quick and just use it. So I try not to confuse the thing. But because there isn't an equivalent to an else if in Scheme, or at least not one that I'm familiar with, the cond kind of fills that void for being able to ask multiple questions and respond accurately. All right, so that makes sense? Ifs and cons. So here, I'll throw that. So we have a cond. That's cond like this, followed by bool expression, true expression, bool expression, true expression, and then optionally you can have a else catch-all expression. But you don't actually have to have that else if you don't want to. So you can say, if it's this, do this. If it's this, do this. If it's this, do this. And if it's none of those, just don't do anything. You don't have to have an else. All right. So, nope. Good.
Like the program that you do with the content, how do you run that thing? Like, do you need to name it something?
Well, no, it'll already run here. So A is 15, right? So we'll hit this cond. Is 15 greater than 5? Yeah, 15 is a bigger number than 5, right? Okay, that's not a 470 concept. Okay, we're good with that one? Okay, so this guy's going to boil down to a 20.
Trick question, we're not using enough.
Oh, hold on.
It's a precision.
Sorry. 15 is not less than 5. So I actually asked the wrong question than the code says. So is 15 less than 5? No, it's not. So this does not fire. Is 15 greater than 2? Yes. So the 7 is what actually fires. So these two things, as is, are functionally equivalent.
And immediately returns once it hits a true, right?
Yeah, but see, that's the thing. That's why I'm really trying to focus on this thing. In past programming classes, I've introduced a keyword called return, right? What does return do? If you had to define the return keyword in, say, Java, what would you say it does?
Hey, Luke.
Yeah.
The return keyword returns the type of the function that it's part of.
Okay, so it returns a value from a function,
Yes.
right? And it also causes that function to immediately end.
Yes.
All right, so technically, a return does not actually have to return a value. You can use the return keyword in a function in Java in a void function.
Really?
Yeah, you just don't want to return something. You could just say return semicolon. That makes the function die. It ends right there. Okay, but if the function was a void function, you definitely don't want to put anything after that return because that function doesn't return a value. Okay, so the return statement makes a function end. It can optionally return a value. Now, the function itself boils down to the value that was returned. Okay, now we've all heard me say that phrase before, right? Boils down. Okay, because ultimately, after and kind of a synonym with it, I'll say something like resolves. Okay, a variable resolves to its value. When if I just type in A here, that's an expression. So if I type in A and I press enter, what is it going to boil down to? 15. Why? Because I created a variable here named A equal to 15. When I put the expression out here, A, it's going to say, I see something that's likely a variable. I'm going to go look up that variable and resolve it to its value. It will boil down to that variable's value. The value of A is 15. Now, Austin, what will that boil down to? Yep.
Hey, there we go.
All right. So last night, Austin was asking for clarification on what this quote means. Okay. That quote means do not execute the thing after it. We've seen the quote in terms of, I've shown you like a list like this. Because remember, in Scheme, the core fundamental syntax of Scheme is list where the first element is a function, and the rest of the elements are the parameters, the inputs to that function. So if I do quote 1, 2, 3, it's going to say, don't execute a function called 1 on the parameters 2, 3. Just treat this as whatever it is. This is the list 1, 2, 3. As opposed to 1, 2, 3 like that without the quote, it's going to try to apply a function named 1 to the inputs 2 and 3, and it's going to scream at me saying, expected a function after the open parentheses, but received a 1. There isn't a function called 1. Make sense? Go ahead.
I guess one thing that, just in general, the first, like, value, I guess, that statement after an opening parentheses is a function.
What?
I guess,
So you're asking this, like 1, 2, 3, if you always have an opening parenthesis, is the very next thing a function name?
Yeah.
Yes. Unless there was a quote.
Okay.
Yep. So, but the same thing is true here. If I just say A, the scheme interpreter is going to look at that and say, I need to figure out what kind of animal I'm looking at. I don't see a quote, so my job is to resolve whatever that is. So it's going to look at that and say, okay, well, I don't see an opening parenthesis, which means it must not be a function call. So I see something else. So it's either an error or it's a variable. So I'm going to go and look up that variable in my variable environment. I'm going to find the 15. But if I put a B here, it's going to say this variable is not defined. It looked for it. It went and checked the variable environment, said, I looked everywhere, didn't see a B. Got nothing for you. Yeah.
And if you just press the enter, then it's giving you 2, 7, right?
Who?
So
If I do this, you hit run? Yeah, it's going to give me a 7 as the result of this if, and then a 7 as a result of this cont. Okay, because since A is 15, we say is 15 less than 5? It's not, so we do not do that. Instead, we do the false expression, which is this if. We say is 15 greater than 2? It is, so we boil down to the true expression there, which is the 7. That's that 7. For this cond, we ask the question, is 15 less than 5? It's not, so we don't do this. Is 15 greater than 2? Yes, so we do this. That's 7. So it'll be 7 and 7. Go ahead.
I guess one thing I'm not sure I understand with the quote thing is nested lists. Why, if you have a list inside of a list.
Why don't you need a quote on the inside one?
Right, especially if it's not the first element.
Right. So he's asking this. If I have a list like this with another list inside of it, like that. In fact, let me steal it up here so we can do some experimenting on it without me having to retype it a zillion times. So I'll define this to be B. So now we have a variable named B. All right. So, and then I'll also create a variable named C where I will have a quote here. So here's the B, there's the C. So notice that this guy is a list containing 2 elements. The first element is a quote, the value quote. The second element is a to list containing 2 and 3. Make sense? Now, your question is this. Why doesn't it try to execute that guy? And it would if we pulled that out of it and actually tried to apply it. There is a function called apply. Pretty sure it's called apply in this version of it.
Okay, so if we were
So apply 2, 3. Yeah.
So if we were to
So-
call cutter, we would get.
Yeah, so on B, if we called the catter of B, that gives us that list. So if we said apply the catter of B, it gives us the error about it's the 2, 3.
Is there a print statement?
Oh, sorry. Say this again.
I said, is there a print statement in this language that you can use to debug or something like that?
Sort of. There is a debug thing that lets you walk through one line at a time. It's a little bit funky. You can try it. Apply actually works a little differently than I'm advertising. So apply will let me do something like this. Apply the function called less than to the value a and 2, something like that. Oh, so does it want apply less than to a2? Function after the it wants the parameters first. So apply is wants that to be a function name.
It takes a function and then an argument list.
Yeah, I tried to give it a function and an argument list up here. Apply function name argument list. Expected function after the open parentheses received the value 15. So it's expecting this guy to be a function. Oh, unless it wants me to do this. Apply less than a2. It found only one. It wants 2 arguments. Apply less than. Well, here, let's just try. Why does it want apply a2 to the function less than?
You have to put a single quote before the
a2.
It didn't work.
Apply. Yeah, I don't know. I'd have to look up how apply works. But the short answer is we can use apply to apply we're going to write our own version of apply, which will take in a function name and then some parameters. And we could apply that function to those parameters. So it's something along the lines of what we're writing here, where less than is the name of a function. The parameters we want to apply it to are those guys, and we're just using the wrong syntax for that. So we can extract a list from inside of another list that happens to have a function call in it, and then apply that to some parameters. Okay. So we now know how to ask questions in Scheme, right? Repetition. All right, so the way repetition works with Scheme, I already told you you're not allowed to use the loop function. So we're going to accomplish this through functions and recursion. All right, so now this is where things get kind of fun with Scheme. We have something called a lambda expression. All right, so a lambda expression, the definition of this guy is an unnamed function. What's a function? If you had to give me a concise definition of a function, what might you say?
a block of code that executes a specified commands.
Okay, in terms of some inputs,
Yes, in terms of
right?
Yeah.
So functions 0 or more inputs, parameters, and then 0 or more lines of code. So we could actually just call this logic to be performed in terms of the inputs. That makes sense? That's what lambda is. So my guess is that's probably what apply is complaining about. Although actually less than should be a lambda, but whatever. So for example, if I say, well, let me write it up here. If I create a lambda here, so lambda is an unnamed function. And you just told me that functions have parameters and then have a body, have logic. So this lambda is going to take 2 parameters, let's say. And then the body of this guy is going to add those 2 parameters together. That makes sense? That's a function, right? This function takes 2 inputs, A and B, and it boils down to those 2 inputs added together. But now the question is how do I call this function?
You can define it.
I have to name it. I have to define it. I have to name it. So I can say define my add func to be equal to that value. So now I have something called my add func, and I can pass it a 2 and a 3, and it'll boil. The 2 will come in for A, the 3 will come in for B, and this will boil down to a 5. Make sense? This is nothing new. You've done this in Java for all these years. You just didn't think that you were actually creating a name value pair with your functions. Over here in Java, we have a name of a method, main. Here's its parameters. Here's its body. If I take main off of there, now it's a lambda expression. It has no name. But somebody's going to want to call main. The Java virtual machine, when it first runs, it's going to look for a function called main and call it. And it's going to get no variable or function name found. Error right now. So we have to give it a name. We didn't have to use a define statement because that doesn't exist in Java. Instead, the way we define a function is by giving it some keywords, including a return statement, a return type, rather, a name. Here's our parameters that all lambda expressions have, and then here's the body. Go ahead.
How do you call a lambda expression for the name?
You use it directly. So I could steal this. That's the body, right? Or that's the actual lambda expression, not with the define. So I can say, take that guy and apply it to 4 and 6.
What's point is cool, I guess.
Well, there's plenty of points. We'll come back to it in a second. But this is nothing new. Didn't I say if you have a list and you don't have a quote in front of it, what must the first element of that list be? A function. Isn't that a function? It's an unnamed function. Unnamed functions are still functions. Right? Looks a little funky, looks scary. Man, it's going to get way worse than this. It's going to be so good. So it's still a function, and what are we doing with it? We're giving it these 2 inputs, 4 and 6. But now, when we write functions, why are we usually writing functions? To reuse them. If we want to reuse the function, it's probably in our best effort or best interest to give it a name. Okay, same thing. Why do we create a variable? Why do we create this variable b and give it a value. The idea is that we're going to use the value that lives in B more than one time. Make sense? Otherwise, why put it in a variable? If they're only going to use it once, hard code the value. Make sense? All right. So functions, what books will typically say is that in Scheme and in Lisp, functions are what are called first-class values. They don't distinguish themselves from ints or chars or strings or lists. You know, when we think about variables, a variable is a name-value pair. Value can mean a lot of different things, right? In Java, our values are any of the primitive types, any of the object types, and I just showed you that under the hood, in a weird syntactical way, a value could be function. In Scheme, it's not quite as under the hood. A value can be a lambda, right here. I'm creating a variable. My variable name is this guy, and the value is this dude right there. Go ahead.
I have a question. How can it know what variable that you put into that function? Like, how can it know if it's an integer or a float or like a string?
Well, because it's an interpreted language, it has a type inference engine. So when it doesn't know. What you're really asking is, I'm not defining what I expect A and B to be, right? Nothing keeps me from saying, my add func, passing it the list 1, 2, and just randomly the value 5. Not going to work. But nothing keeps me from doing that. My add func is a lambda that expects 2 parameters. How many parameters have I given it? 1, 2. Hey, I gave it 2 parameters. They're just not the kind of parameters it was expecting. Because it's going to come over here and it's going to try to apply the function called plus to those 2 parameters. So it's going to try to add 1 and 2 to 5. And it's going to say, well, plus expects a number as the first argument, and it was given the list 1, 2. I don't know how to operate on those types of parameters. Make sense? So we do not have a way in Scheme, or really any interpreted language, to define the type of values that we expect. This is no different than JavaScript or Python, PHP, Ruby, Perl, any of those languages that are kind of our webby interpreted languages. One of their telltale signs is when you define variables, you don't associate a type. Which you can say, oh, well, that seems easier. It also has the side effect of A, making it slower, and B, allowing bad programmers to sometimes not know why they suck. It's like, well, this worked last week. You've ever heard somebody say that? I got students come to my office all the time. It's like, oh, well, I know this works because it worked the other day. How often do you think it's the syntax's fault instead of the programmer's fault? Never. It's never the syntax's fault. I've yet to find a situation where, oh, you're right, a curly brace there used to work. Okay, but the last 2 days they've patched that, and that's not. I believe you. This worked on Tuesday. So yeah, rarely does that happen. Yeah.
If I give it 2 float number, it should add together, right?
Yeah, if I gave it floats.
How about string? It's not using for string.
I don't think concatenation works in add func, but if I gave it 2.5 and 7.3, it'll add them together because those are addable things. My add func. needs a number. Actually, we saw that a few minutes ago that said it wanted the first value to be a number. There is a function, I think, called concat or something like that, or maybe it's just called cat that will let you glue those things together, but we're not looking at that now. All right, so we understand lambdas, unnamed functions. Okay, and now we know how to name them, but we already knew how to name them because we knew how to create variables. All right, lastly, recursion. What's recursion? Recursion is when a function calls itself. And usually when we first look at recursion, we use factorial as our example. What's the factorial problem? So 4 factorial, I'll just put it up here. 4 factorial is 4 times 3 times 2 times 1. But we can also write that as 4 factorial is equal to 4 times 3 factorial. 3 factorial is equal to 3 times 2 factorial. 2 factorial is equal to 2 times 1 factorial. And 1 factorial is equal to 1. So we can define the factorial problem recursively. And we can write that in scheme. So we can say define fact to be a lambda. I'm actually going to kick this down just so it lays out a little bit better. So I'm going to define fact. Here's its value. Its value is going to be a lambda that takes a single parameter. Could be a 4, could be a 5, could be a 6. Some parameter I'm calculating the factorial of. We're going to ask the question, if equals n1, boil down to 1. Else, boil down to the current value of n multiplied by whatever's return of fact n minus 1. Okay, so I have a variable called fact. It's equal to a lambda expression. Lambda expression is a function. This function takes one parameter, n. We ask a question. If n is equal to 1, the factorial of 1 is just the 1. That's what ends our recursion. Else, this is the false expression. I'm going to boil down to the multiplication of the current value of n along with whatever factorial returns for n minus 1. 4 times the factorial of 3. 3 times the factorial of 2. 2 times the factorial of 1. The factorial of 1 is 1. So there's the factorial of 4. There's the factorial of 5, so on and so forth. That makes sense? Okay. So, where's my mapping? Repetition. We have functions and recursion. Guess what? You now know scheme. Every programming language has facilities for these three things: memory, asking questions, and repetition. Do we know how to define things? Do we know how to ask a question? Do we know how to do repetition now? Do you think we can solve a huge classification of problems now with scheme? Where all we need to do is like guess at one of the Boolean operators, like does less than exist, does greater than exist, that kind of stuff. Make sense? All right. So what I'm going to give you out of the book is I'm going to give you a couple of the starter exercises for doing some scheme programming stuff for Monday. I'll go and look at it. I'll probably just give you a couple of functions just to get you warmed up and scared. So I'll put that up here shortly after class as an assignment. I'll also give you a little bit more reading, and I'll put it in terms of sections because I know some people have some different delivery methods of the book. So instead of giving you page numbers, I'll give you sections, 1.1, 1.2, 1.3. But make sure you're dealing with the correct version of the book. It should be the 3rd edition. Has the little QB thing on the front of it. The 2nd edition is nearly identical. It's very, 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 very similar, but there will be some differences. So I'm always going to be giving you stuff relative to the 3rd edition. All right, make sense? Questions, comments, concerns, bribes. Now you all can say you know another programming language.
True.
All right, see everybody on Monday.